Okay, I'm just going to quickly go through the test answers from just before half term. Now, I'm not going to do question 1 because everybody got it correct. So let's have a look at question 2. Alan's laundry contains 2 green socks, 3 red socks, and 7 black socks. He selects one sock in the laundry basket. Primary on property, the sock is red. So we got 12 socks altogether. 3 of them are red. So the probability it's red is equal to 3 over 12, which equals 1/4. So for part B, find the probability the first sock is green and the second sock is black. So we want the probability we got green followed by black. So green is going to be 2 out of 12, and we don't replace it. So we're going to have 7 black ones out of 11, which gives us 7 over 66. And then for part C, I'm just going to do this. So we got probability selects 2 the same color. So that's the probability you got green, green, plus the probability you got black, black, plus the probability you got red, red. And that's going to equal 2 over 12 times 1 over 11, because you lose one of the greens and you lose one of the socks, plus 3 over 12 times 2 over 11. Again, losing one of, sorry, that's the red ones I've done in the wrong order. That's black. So doing black now, and we've got 7 over 12 times 6 over 11. And if you work that all out, you should get 25 over 66. Moving on to question 3. We want to find the value Q. There are 25, so we just take all these numbers away from 25 and you get Q is equal to 5. For part B, the best way to do this is just to put it straight into your calculator. Go menu 2, and we're going to put the value, which is the number of dental fillings, in column 1. So we go 0, 1, 2, 3, 4, 5. Let's just delete the rest. Okay, and then go across and put the top ones in. So we go 4, 3, 8, and we got 5 for Q, and we got 4. And these are the frequencies. Okay, and we'll just delete the rest again. I've not typed those in correctly, so let's go back and just do that. So you've got 8, 5, 4, 1, and it's worth the 1 in, and it's worth just going up and just checking through those numbers again. Now, when you do the calculations, check you've got your one variable x list as list 1, and your frequency is going to be 1 if you're doing one variable. We haven't got a frequency equal to 1. That's what most of you probably did wrong when you made a mistake on this. We want list number 2 for the frequencies. Okay, because I'm putting all the frequencies in list 2. So always check your setup when doing calculations using lists. The 2 variable should never change. You're always doing list 1 for your first variable, list 2 for your second variable, and the frequency is always 1. You always get paired in individual cases, but when you've got one variable, you have frequencies, you often put those in list 2. So let's just put that in and go to one variable calculation, and we can see the mean number is 2.2. That's x bar. So part 1, we get 2.2. Part 2, the median, we want to scroll down and find the median. The median is 2. And for part 3, we want the standard deviation, which is sigma x, which is 1.385 or 1.39. So it's 1.39 to 3SF. Remember, in IB, everything's to 3SF. Okay, moving on to question 4. Again, we're just going to put these numbers straight into our tables. Now, this is going to be 2 variables. You've got time is x and calories is y. So let's put 10 in, 15 in, 20 in, 25 in, and 30 in. Delete the rest. I think it was just that one. Go up and put 90 in, 125, 200, 300, 375. And we can delete that one. And we're just going to do a regression on this. Okay, we're doing x regression and we've got ax plus b. So let's press that. So we get the equation for part A is going to be y equals, the a value is 14.9 x and the b value is minus 80. Okay, find the correlation coefficient. So r is equal to 0.989, which means we have a very strong positive correlation. Okay. Now, so the more calories burned, so the longer we spend walking, the more calories are burned. Okay. C, to estimate the number of calories burnt in a 17-minute walk, what we can do is we can put this equation into, actually I think you can even copy the equation. Copy, I did put it in, cool. So it's put it in there already. So if you press copy, it takes you through now, and it does that. Let's just delete this. We don't need that. We go into the copy. Oh, I copied it twice. Let's just draw this, shall we? Go to menu 5. I'm just going to delete that so I don't have 2. And press draw. Okay, let's go up. Weird. Okay, let's go exit. Go down. Press execute. No item is selected. That's really weird. Okay, so let's just go in there and then press execute. And now I'll try and drawing. There we go. And we've got our line. Doesn't matter if my scale is on here, but I want it to go up to 17. So I need to at least change my view window up to 17. So I'm going to change that to 19. While I'm at it, I'm just going to make, maybe I won't make the y-axis different. So I can now do graph solve and I can find the y calculation when x is 17. And it gives me a y value of 173. So we're at 173.3. The alternative is just to do y equals 14.9 times 17 minus 180 and work it out. And you'll get 173.3. Okay. Is this valid? Well, it's within the range, so we're not extrapolating, so it's a valid calculation to do. And given the high correlation, it's going to be accurate. Right, this is a question we all struggled with. So what we're going to do, we're going to put this straight into our function. And we're going to put a fraction in. And we're going to do 3x plus 2. Put that over x minus 1. And then we're going to do add 5. And we'll draw that and we'll change the domain in a second. It's a bit rubbish. So view window, our domain goes from -3 through to 5. I'm going to change my scale from minus, 100 to 100. And draw that, see what I get. So I get that graph there. So what you can see is you all mostly drew this quite well. Okay, you should have straight lines here. For speed and getting this video out, I'm just going to leave that as it is. Now, what you should have is an asymptote at 1. Notice there's an asymptote at 1. There's also another asymptote here. Now, how do you find this asymptote if you're not sure what to do? The way to do it is going to be 5 plus whatever this tends to as x gets big. Now, if we ignore the 2 and the -1, they don't get big. You've got 3x over x, which is just 3. So as x gets big, this is going to tend towards 3 plus 5, which is 8. So our limit will be 8. And if you can't remember that, just do trace. And just trace along the thing and see what happens to the y value as x gets very big. And you can see on here it's getting towards 9. And if we go all the way back, just see if we press the trace button, it might get us back a bit quicker. Okay, where's the trace button? Okay, there we go. To go all the way back, you see it's getting closer and closer to 8. And it's not really quite enough for us to know that it's 8. One's 7 point something and one is 9 point something. If you change your axes, your view window, so the x-min is something like minus 1,000 to 1,000, then it makes it much easier to see what it's going to be. So if we draw that and then do the trace and go left, you can see the y value getting really close to 8. And now it's not unreasonable to think it's going to be 8. And if you go to the right, what we see is it's going to flip to just above 8. So it's not unreasonable to say that this is y equals 8 and this is x equals 1. So our graph's going to look like that, and it's going to look like that, and we should find these crossing points. So let's just graph solve, and we can find the y-intercept, which is at 3. And then do graph solve again, and we can find the roots where it crosses. It might be because let's just do that. I think it's because we're on the wrong side. It's not finding the root. That's really weird. Let's just draw again. Let's just draw again and get a better view window. So view window, let's go to -3. I'm not sure why this is not working on this, but let's go back. And it should be easy to see that we've got a value here. Let's just try graph solve, and we can find a root. There we go, it finds it now for some reason. It couldn't find it earlier. So going into the range, we can see that this is going to be at 0.375. So there you go. So there's some difficulties spotted in using the graph to find certain things. Find the range of the function of f in the given domain. Now, because we're at -3 here, and because we're at 5 here, we're not going to get very close to 8. So we find out what f of 5 is. So f of 5 comes out to be 9.25. So we know at 5, the range part is going to be, all this bit's going to be bigger than 9.25. And f is -3. So here's a -3. And we do f of -3, we get 6.75 when we put it in. So you just put 5 into here, and you put -3 into this. Or what you can do, if you've got the graph already up, is find the y calc when x is -3, and it gives you 6.75, and we can do the y calc when x is 5. And put those in, because those are the limits of the domain, so they're going to affect our range. So we know that f of x must be greater than or equal to 9.25, or it's going to be less than 6.75. Okay, because all of this bit of the graph is lower than 6.75 on the y-axis. All this bit of the graph is more than 9.25 on the y-axis. There is nothing in between because of our restricted domain between -3 and 5. This is our domain. Remember, domain is the x-axis, range is the y-axis. Okay. Now, it's asked us to find g of x equals x minus 2. And we want to find when x minus 2 effectively is bigger than 3x plus 2 over x minus 1 plus 5. Now, you could solve that algebraically, or what you could do is just draw x minus 2 on here. Let's go into here and draw x minus 2. Press draw. And then we can, and we're just doing this for our domain, so we can just draw graph solve, and we can find the intersections. So we've got an intersection, x is 0.475. So if we draw this, let me just get another color pen. So if we were to draw this, it's going to be crossing at 0.475. So it's going to cross like this. Okay, there's 0.475 just there. Okay, so for part C, we know that f of x is bigger than g of x up to here. And that g of x, until we get to this x is 1 bit, is going to be bigger than f of x. So therefore, we've got that. That is going to be bigger than 0.47. Sorry, my writing's gone big. 475 is going to be less than or equal to x. Okay, because and then up until we get to there, we know that g of x is bigger. And then once we go past here, f of x is bigger. Yeah, f of x is up here is bigger. And we don't need to consider further than here because the domain is only up to 5. So we don't need to go beyond 5 because the domain was only up to 5. So in this range, 0.475 is less than x, and x is less than 1. Because when we're at 1, the graph flips round, okay, and suddenly f of x gets bigger. Okay. Right, that was probably the hardest question on the paper. Moving on to question 6. There's another one we just typed straight into our calculator. Just exit from here. Menu 2, and let's type these in. 88, 85, 74, and there's a few settings you've got to remember when doing this t-test. Remember, pooled is always on for t-tests in your syllabus. Pooled is always on. And when we come to actually doing the calculations, you've got to make sure we're in lists and not variables. Just doing a bit of catch up. Okay. So what we're putting in here, 103, 88, 94, 97, 105, 132. Okay, so we put those in, and we're going to do a test, and we're going to do a t-test. It's a 2-sample t-test. My data is in a list. Now, we want to write down an alternative hypothesis. Right, we want to get the alternative hypothesis first. So the null is that. So the null is always written as H0, and the alternative is always written as H1. Remember that. So 2022, we want to see if it's increased in 2023. So therefore, the mu of 2023 is going to be bigger. All right. We want to find our p-value. So let's go down and just change your hypothesis to that. And then just go down and check my list 1, list 2s are correct. And notice pooled is off, and I'm going to change it to on. Okay, so always make sure you check the pooled bit. And press execute. And we get a p-value is equal to 0.04856. So it's going to be equal to 0.0486 to 3SF. Remember IB, we do 3SF if not told otherwise. Hence take the conclusion of this test. So we've got to compare this value with the significance level. Here we go, significance level 10%. So that's going to be 0.1. So that's less than 0.1. Therefore, reject H0. So we either reject H0 or do not reject H0. You do not reject H0 if the probability is big. You always reject H0 if the probability is small. Okay, so that's your conclusion. And we're given our reason by the fact that the probability p-value is lower than the significance value. What does this mean in the context of the data? It means that there is evidence. Now, we'd never be certain on saying this bit. Never be certain. There is evidence to suggest. Always start off with there is evidence to suggest, or there is not evidence to suggest. Okay, if we're finding the other thing. There's evidence to suggest his free kick speed has increased. Okay, use these words because they give just the cast of doubt, because there is no certainty in hypothesis testing, it's only probabilities. So therefore you never say it's proved, you never say, well, we've shown, you just say there's evidence to suggest, or there's not evidence to suggest. Just like the either reject H0 or do not reject H0 is your standard one. Say evidence to suggest or there is not evidence to suggest. Okay. Right. This one, we didn't do very well on the differentiation. So write f of x is equal to 3x minus, now this is the same as 2x to the minus 2. All right. Now, if you're not sure how to put this into powers, why not draw a graph of 2 over x squared and draw a graph of 2x to the minus 2 and see if they are exactly the same? Yeah, if you've got time, you can always check that and see if you've got that indice bit right, or put some numbers in to check. Now, f dashed of x, we differentiate this, take 1 for the power, so that's x to the 1 goes x to 0. X to 0 is 1, so we're just left with 3 times by the power is just going to be 1. So we're going to times by the power, so it's plus 4, minus 2 times minus 2 is plus 4. Take 1 off the power, minus 3. A lot of people did minus 1 by mistake, which is adding 1 onto the power, and that's your answer. Part B we were much better at because we remembered we can just put the graph into the calculator. So let's just put the graph into the calculator. So what was it? 3x minus 2. That's actually what you would do is you'd put the one that was given to you. So let's just turn this into a fraction. Always make it look like what you've been given. So we've got x squared. Okay. Go down, press execute, and let's just delete this one. We can draw it. And we want to find the equation of normal. So we're going to go to sketch, and we want the normal. And we want the normal when x is minus 1. And if you press execute again, it doesn't give you the equation. Oh, it does give you the, no, it doesn't give you the equation of normal. Now, if it doesn't give you the equation of normal, that's because I've got derivative in my setup on off. So I'm going to put it on and press execute. Hopefully you've put all your derivatives. You set up your function, set it up, press shift options. Sorry, not shift setup even, and check your derivatives on. Also check that your angle is in degrees because you don't need to use radians. Okay, make sure your angle is always in degrees. So worth doing that now before the exam. Anyway, press draw, and we're going to sketch, and we're going to get normal. Press X. We want minus 1, and we press execute, and it gives us the equation y equals x plus 4, or minus 4 even. Okay, now find the other 2 points where this normal intersects the curve again. So if we press exit and then type in x minus 4 as another equation, press draw, and then we're going to press graph solve, and we're going to find the intersection. So the first one is where x equals minus, well, actually it wants coordinates, doesn't it? So let's put minus 1.62 to 3SF, comma, y is minus 5.62 as our first point. Here we go. Press along, and that gives us the one we've already got. Press along again, and we get the other one, which is 0.62, comma, minus 3. Actually, I should have got an extra one. That was 183SF, 3.38. Okay, so do remember, you've got to remember how to put the normal into the curve using your graphical calculator, and then type the equation in, and you can find out where they cross each other using your graphical calculator. Okay, so find the angle of AOB. So we're looking for this angle here. We're told that AB, now unless it says arc AB, they mean the straight line distance AB. So we know that we got that distance is 20, and we know that that's got 16. And we want to find theta here. So theta, we've got the opposite, we've got the hypotenuse, so we've got sine theta equals 16 over 20. So theta will be equal to inverse sine of 16 over 20. So let's go menu 1, and let's just put that in shift inverse sine 16 divided by 20, execute, and we get 53.13. So that's theta, and we want AOB. Therefore, AOB will equal, times that by 2, and we get 106 to 3SF. Now do remember, although we've rounded that to 3SF, for the rest of the question we're going to use this whole number. Now what we need to do next is find the area sector AOB. So that's the whole of this area. So you round there, to there, to there. And we're going to use the formula for part B. Area for a sector is equal to theta over 360, the fraction of the circle, times by the area of the circle. So times by R. So we're going to do this value. So we're going to use the answer. Divide it by 360. Times by pi, and then we're going to times that by 20 squared because the radius I do believe was 20, and we get 370.91, which equals 371.23SF. C, find the shaded area. Well, we just need to take the area of that triangle. Now if you had to find the area of the triangle, remember you can use half AB sine C. A is that distance, B is that distance, C is the angle between the two sides if you had to find the area of that triangle. So do 371 minus 192, which gives us 179 to 3SF. Now notice I didn't bother using the full value here because this is given to the nearest integer and this is to the nearest integer. Take them away, I'll get the right answer. Okay, that's the only reason I didn't do that. Right, normal distribution, moving on. So, the marks achieved by students of college entrance exam follow normal distribution with mean. So we've got X is going to be normal distributed and mean is 300 and the standard deviation, we always quote the variance. So standard deviation squared is the variance. Okay, and we've got 10% score greater than K. So the probability that X is greater than K equals 0.1. So we're undoing a normal distribution, not finding a probability, we're given the probability. So we go to menu 2, and we go to distribution, we go normal, and we go to inverse normal. And my tail is, because it's greater than, we're looking at this area here, my tail's to the right. And my data is in a variable, not a list. I haven't got a list of variables. I just got the variables here. And I'm going to put the area as 0.1. That's a probability. My standard deviation was 100. And my mu was 300. Press that and I get the value here is 428. So K equals 428.155, which equals 42823 SF. Now, moving on. So we want to find the probability that someone gets accepted. So P of X is bigger than 430. What we're going to do is we're going to go exit, and we go distribution, go normal. We want to find the probability that somebody's bigger than 430. So put that in, put in something ridiculously large here, and we've got the same mean and standard deviation, and we get our probability, and that comes out to be 0.0968. So for part C, 2 independent students are chosen random. What's the probability that one would be accepted by Taylor College and one wouldn't? So we want the probability that one is accepted and one's not, or probability that one is not accepted and one is not accepted and neither is accepted. So you can do it in 2 different ways. So basically we've got the probability accepted, which is this, 0.0968, times by the probability not accepted. Well, it's going to be 1 minus 0.0968. And then we've got exactly the same probabilities, just in a different order. We do this times this in the other order. So effectively we can times that by 2. So if we take our answer, 0.968, and go menu 1, so we're going to do 0.0968. There's so many just zeros after that, it's not worth doing the next bit. 1 minus 0.0968, close brackets, times by 2, and we get 0.17485, which is 0.175 to 3SF. I didn't use the whole number because this is 3SF, then you had two noughts, which takes you to 5SF. Using 6SF, it's not going to change to 3SF, the answer. So I was able to speed up my calculations by not having to take further digits, but you should always take the full digits just in case. Okay, moving on to question 10, and what we have here is, this function, which is an exponential function. It's got c to the minus t, so it's not an e to the minus t, it's a c to the minus t. And we're told initially there's 2 grams of yeast in the solution, find the value of k. So initially is when t equals 0. So part A, you got t equals 0, and we know the value is 2. Now this g of t, so g of naught, is saying g of naught is equal to 2. Now some people got confused and put the 2 in for the t. So, but actually g of naught is 2. So what we're saying is that thing there will equal 2. Then you got 10, and then you got minus k, and then you got c to the minus 0. Now minus 0 is 0. Anything to the 0 is 1. So you got 12 equals 10 minus k. Alternatively, you could just put that whole thing. If you don't know what c to the minus, well, actually, you're going to struggle to put c into your calculator. I was going to say, if you didn't know what that was, you could put it into calculator and press the solve n button, but it's much easier to just do this. K on this side, 2 on that side, so k will equal 8. Now moving on to B. After 3 minutes, there's 9 grams of yeast. Now you're probably going to, so therefore, the g of t is 3, g of 3 is 9. That thing is going to be 9 equals 10 minus, we've got k, 8, c to the minus, what we've got, 3. And now what we can do is you can put this into your graph solve. So we're going to, sorry, not your graph solve, your solve n. Go into maths. That's not maths. Option calc, sorry, solve n, and we're going to solve 9 equals, the equals button is just here if you press shift, 10 minus 8 times, open brackets, we're going to call this x rather than c, to the power of minus 3. Close that brackets, put a comma, and we'll tell it the variable is x. Now you can specify the range of values you want it to do in. Actually, you've got is greater than 0, but we won't bother with that. We'll just put the closing brackets and see what happens for our first one. And we get an answer of 2. I can show you how to do it algebraically if you really wanted. And effectively, you've got, take the 10 from that side, you've got minus 1 equals minus 8 over c cubed, so therefore c cubed will equal 8. If you bring that up and divide by minus 1, minus 8 divided by minus 1 is 8, and you just get the cube root of 8, which is 2. That's the other way to do it if you do the algebra. Part C, write down the maximum amount of yeast in a solution. So what we're going to do is we're going to put this function into our graph solving. Okay, for maximums, generally put them into your graph solving. So what we're going to do is we got 10. Let's just delete everything. So we've got 10 minus, and k was 8, times, open bracket, 2 to the power of minus x. And put a close brackets around that. Let's just press execute, and let's just delete this one from previously. Press draw. Now, we know that it is for t is greater than or equal to 0. So let's just change our view window. So our x min is 0. Let's just put in a little bit longer than 5. Let's put in about 20, just for good measure. Probably don't need x or y min. Sorry. As I say, we probably don't need a y min of minus 100. We definitely don't need a y max of 100. So let's just do view window and change those into, let's go -1. Let's try 10 here, see what happens. Sorry, going back to the graph, what we see is it just keeps going up and up and up, and it tends to a value. Now, again, we could use our trace button here because the maximum didn't work, and we could trace and see, look what's happened to the y value. You see it's getting closer and closer to 10. And if you think about it, here's 10, and you're taking away 8 times a number to a negative power. And if you do negative power, that makes the number very much smaller as you get bigger on the value of t. So therefore, this is getting smaller and smaller and smaller as you're taking a smaller and smaller value away from 10. So therefore, 10 will be our maximum value. Okay, never actually reaches 10. Okay, but again, the limit of this function is 10. So saying the maximum amount of use is 10. It will be to whatever number of places you want, it'll be equal to 10. If you do 5, you go far enough, it'll be 10. If you do it to 10 places, you go far enough, it'll be 10 to 10 decimal places. So actually, we can probably write down 10 as our best answer for this. Question 11. Right, so we had to draw a house. So this is our house, I think, or wall. Okay, yeah, using one wall house. And he's got 60 meters to enclose a vegetable garden. Okay, and we're going to have y is going to be the length and x is going to be the width. And we can see that x plus y must equal the length of the fence. Okay, so that's part A, this is part B. So therefore, 2x plus y will equal 60. And that's probably the best way to, and most concise way to explain it. Show the area of the garden is given by the following equation. We seem to have real problems with this. So the area is going to be the length times width, so it's x times y. Now, we want it only in x's. Now, from this equation, we can see that y is equal to 60 minus 2x. So we're going to replace this y with 60 minus 2x. So we get x, open bracket, 60 minus 2x, because we have replaced this y here, this y here, with 60 minus 2x. All right, that's what we've done. Anyway, and we can multiply that out, and we get 60x minus 2x squared. Now, it wants us to find the maximum area of the garden. Now, we can do differentiation and work it out that way, but remember what I said, to find maximums, we can just use our graphical calculator. So what we're going to do is we're going to delete this function, and we're going to put in 60x. Now, if you haven't shown it, you can still use this equation. Yeah, we can still use this equation to find the maximum. Many people just gave up because they didn't show it. Well, why not use it in the next part of the question? Draw the graph. If in doubt, draw any function and have a look at it. And we can't see very much happening. Well, we know that the length of x can't get more than 60. So let's just change our view window from 0 to 60. Oops, I did it again. 0, go down, go 60. We might... draw view window. So we just want to go down and change our y value, and it's obviously going to be a lot bigger than 10. So let's put 1000 in to start with. Probably ought to change our press execute. We need to change our scale. 500 will do for that one. This one probably 10 is more sensible. Bear in mind we're going all the way up to 60. Draw that, and we can see our graph. And then we can just press G solve, find the max, and we get it as x equals 15 and y equals 450. So therefore, C, x is going to equal to 15. The area is going to equal to 450 for my answer for my maximum. Okay? Moving on. So do remember, if you don't get the equation, you can use the equation to put it into graphical calculator and draw it to find maximum mins. Right, we're going to do a chi-squared test for independence. We want to write down the total number of students surveyed. So we're just going to add 15 and 15 and 10. to 10, 10 and 30, and we get 90. Nice and easy. Everybody got that right. B, write down a null hypothesis. So null hypothesis for all these tests, these contingency table tests, is going to be that they're independent. So drink preference is independent of in-house, outhouse. Outhouse, you might say it's just drink preference is independent of the house you're in. C, find the expected frequency who prefer iced coffee from outhouses. Now I'm going to show you how to do this with your calculator. If you don't want to do it with your calculator, you need to do it. Iced coffee from outhouse. What we do is we take the total of the iced coffee, which is 25, and then we look at outhouse and take the total of outhouse, which is 50, and you do 25 times 50 and then divide by the total number of 90 to get your expected number. But as you're going to be doing the test anyway, we may as well go to menu 1 and go to our matrix and set up our matrix A, which is a 3 by 2, which I've done the wrong way around, so we can edit that. Let's go exit, exit, and dimension it as a 2 by 3. If you don't, I never remember this, and if you don't remember it, it doesn't matter. You just redo it. And then we put the numbers in: 15, 15, 10, 10, 10, and 30. And press exit. They're now in matrix A. Now we're going to go to menu 2 because it's a stats thing. And we want to do a test, and we want to do chi-squared, and we want to do a two-way table test. We put our observed values. These are all observed values in matrix A, and the expected value is going to go into matrix B. So we press execute, and we can look at, and we can press execute, and we can look at that. We've got our p value and a chi-squared value, but we can also look at the matrix. Go down to matrix B, look at that, and then look at the cell which is iced coffee outhouse. So that's 10 on here. And on here is 13.88. So we just write in that value, 13.9 to 3SF. Okay. Find the p-value. Remember what the p-value was? The p-value was 0.4036 times 10 to the minus 3. If you're not sure how to do your decimal places, go 1, 2, 3. There we go. So we get 0.004036. If we're doing 3 significant figures, technically we should be, because we're doing IB, 0.404. Sorry, 0.00404. Now we want to state our conclusion. Now against that, 0.004 is less than 0.05. Therefore, reject H0. So therefore, if we're rejecting H0, this means that drink preference is not independent. Is not independent of house. Okay, it's important. Reject H0. Sorry, I should have written there is evidence to suggest. Because it's not guaranteed, but there is evidence to suggest that they are not independent. Okay, always remember that sentence, which sort of casts a slight amount of doubt on your result, because it's not guaranteed. It's only about probabilities. Right, moving on to Voronoi diagram. And we've got to remember how to go about doing Voronois. So it makes it easy. It wants you to find the gradients that would join B and D. So we want to find the gradient from B to D. So from B to D, we want our change in Y's over our change in X's. So our change in Y's, if we go from, let's go from B to D. So going from 15 to minus 8. So that's going to be minus 23. And from minus 5 to minus 2 is only going to be 3 for our change in X. Now, we want to find the equation of perpendicular bisector between B and D. So here's B and D, and we just found the gradient to that line. We want the gradient of the perpendicular bisector, which is just minus 1 over this. So the gradient of this line will be just the minus reciprocal of this, which is just equal to 3 over 23. Now, we need to find the midpoint, because we need to find a point it goes through. Okay, we need to find the midpoint, so we need to find a point it goes through. So the midpoint of, what was it, BD, that's going to be equal to, so we've got B is minus 5 and D 15 and D is minus 2, 8. It's going to be average of those values. So you've got minus 5 plus minus 2 over 2, comma, 15 plus minus 8 over 2. And we get, what's that, minus 7 over 2? And we get, what's it going to be, 8 of 15, 7 over 2. That's our midpoint. So the equation of our line, if you use y minus y1 equals mx minus x1, is just going to be the y1 and x1 is a point on the line. Now the midpoint is on this line. And we've got our gradient, which is m. So we just write down y minus y1, which is 7 over 2, equals 3 over 23 times x minus minus, so that'll be a plus, 7 over 2. Yeah, you've got a minus gives me a plus. Now, it says ax plus by plus d equals 0, where a, b, and d is a member of the z. Z means integers, which are whole numbers, which are positive or negative whole numbers. So we need to get rid of all the fractions. So, first off, we can times that by 23. That's an easy way to do it. So you get 23y minus 23 times 7 over 2 equals 3. I'm going to multiply out this bracket. It's 3x. 3 times 7 is 21 over 2. And now I can times that out by 2 to get rid of all the fractions. And I get 46y minus whatever 23 times 7 is. Let's just do it. Menu, I don't know off my head, top of my head. Probably could work out quicker than using the calculator. 161 equals 3x plus 21. Now it wants it all equal to 0, so we could get 46y minus 3x minus 182 equals 0. And I just made a mistake because I forgot to times the 3 by 2, so that's going to be a 6, and that's going to be a 6 there. And actually we could cancel down this by 2, but this would be a perfectly good answer because these are all integers. Okay, although it's not totally cancelled down because they're all even numbers. So I could get 23y minus 3x minus 91 equals 0. Also, if we had plus 3x minus 23y timesing everything by minus 1 plus 91 equals 0, that would also be okay as an answer. They're also all integers in this case, so it doesn't matter which way round these are. So that was that test. Right, in this question, there's an extra question from binomial a student found tricky. Kurt and John play one basketball game every night of the week. Each night's game is won by either Kurt or John. There is no draw. Probably John wins any game is 0.75. The result of each game is played independent of any other game played. Let X denote the number of games won by John. Final expression showing the probability that Curtis wins exactly 2 out of 5. So basically what we have here is we have a binomial and the probability of John's success is 0.75 and we've got 7 trials because there's 7 nights in a week. So n is 7. It even tells us 2 out of 7. Now, the probability that Kurt wins exactly 2 games out of 7 is the probability that John wins 5 out of 7. So we want the probability that x equals 5. So we just go to our menu 2 here, go to stats, go to distributions, go to binomial because it's a binomial. We can do BPD or BCD. Most people seem to like using BCD and just putting the upper and lower the same. So they make it 5 for the lower and they make it 5 for the upper. number of trials 7, probability of success 0.75, and then you press execute and you get 0.311 as the answer. So you bear in mind, to 3SF we get 0.311. Right, another binomial question here. The history data of an airline company shows 5% of people book a flight do not show up. If 42 people made a book a flight with a 40-seat plane, what's the probability there'll be a seat available for every passenger that shows up? So what we have here is we have a binomial. So X is binomial. Probability of success is 0.05, and we're going to do it. The number of trials is 42. And we want to find, because there's 42 people altogether. So you could have 42 successes, 42 people all turn up. Actually, this is not showing up. So if I've got the probability this is not showing up, what I want to do is I want to find the probability that X is going to be greater than or equal to 2. Okay, is what I need to find out, because I want at least 2 people not to show up, and then I'm okay. So if I go back to here and I put my lower value as 2 and my upper value as 42, because if all of them don't show up, there'll be enough room for everybody. And we got 42 trials, and we got a probability of 0.05. Press execute, and we get our answer as 0.6276 and so on. So it's equal to 0.62823 SF, or to a whole percentage, because actually it wants a whole percentage. So we're going to do 63% as our answer. So just going back to the workings, our lower value is 2 because we want at least 2 people not to turn up. We can have up to 42 people not turn up and have room on the plane. There are 42 people who had bought tickets. The probability of one of them not turning up is 0.05. And that's how I put this question together. Anyway, that's all the questions I've been asked this week. So this video completes our revision for standard level A&I for this year's exam.